This natural phenomenon, I saw it for the first time just yesterday. It mesmerized me. To me, it was awe-inspiring. What is happening? What is coming down in the ocean and traveling across the floor? Traveling and unrolling like a carpet. What is it doing to these poor starfish? Clearly, they can no longer move. They're stuck in the ice. So many questions. This is the third of 3 heat labs in a series all about heat. This scene, however, implies that there's something cold happening here. So please bear with me as we unravel slightly this very intriguing, to me at least, phenomenon. What include my heat lab series? Heat labs 1, 2, and 3, all presented in one Google document. First heat lab, video linked above, centers around the heat of fusion. I introduced this heat lab by focusing on the Arctic polar ice cap, which, based on recent research, is supposedly going to vanish in terms of sea ice within the next 10 years. The video takes you through my document, including lesson materials and key data collected by my students, as well as possible percent error explanations. I got some help from ChatGPT. Second of the 3 heat labs centered around the specific heat of copper. The introductory phenomenon this time centered around solar energy coming in and increasing the temperature of land much more so than the temperature of the water. What's up with that specific heat? There's less land mass than there's water, but clearly water has a higher specific heat than other substances, including metals. With very few directions, I let my students figure out what steps to take in order to determine the specific heat of copper. But for this second out of 3 heat labs, I do still give them a data table. The third heat lab centers around the heat of solution. Even though the phenomenon feels very cold, there's something about dissolving calcium chloride in water that makes the solvation of this salt exothermic, and thus causing the release of heat. Just like seawater is a solution, so we can create a solution with calcium chloride in water. How much heat is released? Let's unpack the CaCl2 phenomenon. But before we dive into the key associated with this third heat lab, let's take it back a notch. For those chemistry teachers in New York State, this should be a familiar slide because it shows you all the heat associated formulas located in our New York State chemistry reference tables. How would I introduce this third heat lab with my students? Well, I'd go back to the first and the second one. And I do it this way. You see here the Pear Deck interactive slide that can be present on those Google or PowerPoint slides that you wish your students to interact with using the Pear Deck app. And this, of course, means that your students can draw anywhere on this slide. Hopefully, they can at least write down that ice has the chemical formula H2O, is a solid, it contains only non-metallic elements. It is thus a molecular compound. And I would expect my students to be able to write down the fusion formula that enabled him to determine the amount of heat needed to melt ice. What about the copper plate? After completing heat lab 2, students should certainly be able to determine that this is made of the metal copper, Cu solid, and in order to determine the specific heat of that specific metal, you would need this formula, Q equals mc delta T. In this third heat lab, I have students dissolve calcium chloride. Calcium being the metal, chloride being the nonmetal, put the two together, and you get an ionic compound. You mix these 2 substances together, you've turned your 2 substances into a mixture, a homogeneous one, more specifically an aqueous solution. And in order to determine how much heat is either absorbed or released, I hinted at releasing earlier, you need this formula, very similar to the one used for the specific heat of a metal. Here's the actual student handout. Again, this is the third lab within one document. There is some background about calcium chloride. The purpose is clearly stated for students to determine the heat of solution. It does give them some directions, but they just have to take it out of the purpose. 5 grams of calcium chloride dissolving in about 50 milliliters of water. Tap water? Distilled water? Since I do find this third heat lab more challenging than the other two, because there's even less hand-holding, you may wish to wait and do this lab later in the school year after you've covered some other concepts. But because the other 2 previous heat labs are still attached to this document, when you do get to this third one, it's very easy for them to look back what they did before. And by looking over the data and their explanation of error for the previous 2, it should help them figure out how to tackle this third one. How we're going to do this? Well, we got to weigh out some calcium chloride, 5 grams. How much water to add to the calorimeter? I think my directions suggested 50 milliliters. Let's add it to the calorimeter. Don't forget the thermometer. We need a temp 1. Let's add the salt. Let's do some stirring. We want to make sure all is dissolved. Let's get that final temp, whether it's the highest or the lowest. But for calcium chloride, looks like temp went up. Here I'm showing you some sample data and the analysis of this data that I did with my students this past school year. As a handhold to the analysis questions, I'm giving them a specific table. Again, this table comes from the New York State chemistry reference tables, and it shows several heat of reactions for several solvation reactions. And they have to answer questions related to bonding. Hence, this third lab may be better later in the school year. I want to pause at the following question. It's question number 5 that asks students to model the actual solvation reaction. Watch me. Let's first click on this diagram. If you click once, it highlights it. If you double click, you get into the drawing tool. If we click on one of the chemical species, say calcium 2+, and you press on your keyboard Control and D at the same time, whoa, it duplicates that particular chemical species. Let's try it for chloride. You click once, hold Control D, and you've duplicated it. Powerful. You click on water, careful, because you want to select the entire water molecule, Control D, and you've duplicated it. And this enables students to really try and construct a model without starting from nothing. I just undid any of those duplications because I want to keep this as the student copy, but whatever changes the students make, all they got to do is save and close, and their altered diagram should be saved. If anything happens, they can always take a screenshot of their work. Here's my proposed key to the solvation process, showing you in this case 2 water molecules, but 4 sets of these, held together by hydrogen bonds between the oxygen atom of one water molecule and the hydrogen atom of another water molecule. The second reactant is the calcium chloride salt, held together by ionic bonds. I'm only showing you 1 cation and 1 anion. When these 2 mix, the existing bonds, hydrogen and ionic bonds, are broken. New forces are formed, more specifically ion dipole forces between calcium and the oxygen atom within water, and between chloride and the hydrogen atoms in water. And that, of course, has to do with the polarity of the water molecules. I'm also pausing here at question number 6, which asks about a potential energy diagram. Even though I introduced this third lab with the cold brine curtain, the actual solvation reaction of calcium chloride in water causes a rise in temperature, as reflected by the left chemical potential energy diagram. If you're at that point in the chemistry curriculum, you can even bring in not just the concept of enthalpy, but also the concept of entropy. A solvation reaction obviously means that we're mixing the water and the salt, which is favorable in terms of randomness. Delta H is less than 0, temp rise, And the change in entropy, there's more mess, so that went up. And again, it's up to you whether to leave a question in or delete it. This is possibly more of an AP Chem related question because it's asking the students to determine the amount of kilojoules released per mole of reaction. If you don't want to get into it, then make that question a bonus. Heat labs 1, 2, and 3. Polar ice caps are shrinking. Solar energy really increased the temp of land compared to water. And that brine curtain rolling down, that is one heck of a complicated concept. Bringing in not just heat, or should I say cold, bringing in colligative properties, bringing in osmosis, you can decide whether you wish to bring this most complicated phenomenon later into the chemistry curriculum. Not an easy one, but certainly an awe-inspiring phenomenon. This upcoming school year, I plan to introduce the heat concept to my students, as opposed to saving it for later in the year, when officially that thermochemistry unit comes into play. Why? Because heat is really involved in any chemical reaction, when we're breaking bonds and when new bonds are formed. I plan to introduce that heat concept as part of the bonding storyline. The storyline that I've created several videos on. A storyline which really represents a cohesive sequence of lessons and activities that nicely flow into each other, like a red line throughout the lesson set. Check the link above for the summary of all these storyline lessons that I made. And if you missed that brief Dutch lesson on storyline, storyline is a verhaallijn. Verhaal is a story. Lijn is a line. And de rode draad is the red thread that connects all the different lessons to each other, which is why I love this series so much. De rode draad, verhaallijn. Here are all the storyline associated videos in the stunning Storyline on Bonding playlist. I think it's worth checking out, and consider implementing this in your chemistry curriculum. If you want my science resources, go to the link in the description below. It takes you to Astrid's landing page. Click on the Join the Exploration. Using your preferably personal email, it will then ask you to confirm that email address. That will lead you to Astrid's Science Resources, which is a Google document, a live document that I continuously update. Hope you will join the exploration where science meets curiosity. Finally, this was the third heat lab in a series of 3. Make sure to check out the first and the second video because they all come in one package, one document for you and your students. Thank you very much for watching. Bedankt voor het kijken. En tot ziens. See you in the next video.